For homework tonight, please complete page 16 and correct it with this caption. Remember, this is your first homework assignment of trimester 3. A school carnival committee features a different version of the Making Purple game as shown at right. Before playing the game, do you predict that the school will make money on this game? This prediction is completely up to you, so whatever you did for this question, please make sure you've answered what you think and why. Now use an area model to show all the possible outcomes for this game. So I know that in one of the containers, there is a red, a blue, a green, and a yellow. And I know that in the other container, there is a red, a yellow, and a green. So I'm going to go ahead and divide this section into thirds since there's 3 possibilities from that particular bucket. And I'm going to divide this one into fourths because there's 4 possibilities there. And this game is called Making Purple. And so I know to make purple, I need to make a red and a blue, or a blue and a red. So I'm just going to go ahead and note where I have that outcome. And here I see a blue and a red. Are there any other ways to make purple? Nope, just that one. So this is my area model. You can also go through and you can fill in the specific combinations if you'd like RR, RY, RG. Since we're just focusing on making purple today, I'm just going to notice that it's that one section there. So what's the theoretical probability of choosing a red and a blue marble on one turn? The probability of getting a red and a blue, or a blue and a red, is going to be equivalent to 1 out of, up here you'll notice that we have 3 outcomes by 4 outcomes, so that's 3 times 4, or 12 outcomes. So I have a 1 in 12 chance of choosing a red and a blue on one turn. Suppose one marble is chosen from each bucket. Find the probability of each situation. You choose a green marble from bucket 1 and a yellow marble from bucket 2. I'm going to go ahead and sketch my area model here again just so I've got it. So again, it was a red, a blue, a green, and a yellow, divided into 4 sections, and a red, a yellow, and a green across the top, divided into 3 sections. So if I want to choose a green marble from bucket 1 and a yellow marble from bucket 2, so here's bucket 1, here's bucket 2, so a green from 1, that would be this column right here, and a yellow from bucket 2, and they're going to intersect right here, and so I can see the probability of getting a green and a yellow in that exact order is 1 out of 12. Then the probability that you do not choose a blue marble from either bucket. Well, if I notice this column for blue is right here, so all of these are going to have a blue in them, but I do not want to choose a blue. So the probability of not getting a blue is all of the rest of the ones that are there, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 12, or I can simplify that to 3 out of 4. What's the probability of choosing 2 blue marbles? Well, you may be noticing that there's no blue at the top here. And so I can only get a blue and a red, a blue and a yellow, and a blue and a green. I can never get a blue and a blue. So the probability of getting blue is 0 out of 12, or simply 0. That's an impossible event. And finally D, you choose at least 1 blue marble. So P, I'm just going to use 1B here. And again, this whole column right here, this is blue-red, blue-yellow, blue-green. So there's 3 outcomes that have a blue in them. So that's 3 out of 12, or 1/4.